Well, Steve, thank you for hopping on. And this is a continuation of our get together in Los Angeles a couple months ago. You're not an easy guy to get a hold of, so thanks for hopping on today.
Not a problem. I'm happy to be here.
We don't need to go too much into your history. I know you've hashed it out a lot, and I do want to jump into the weeds, but maybe you could give you're walking into a job interview today, and you need to give your 90-second elevator pitch on what you've achieved and been involved with over the past few decades. What would you tell us?
That's a good one. So it's actually been about 50 years. I joined Lawrence Berkeley Lab 50 years ago this year. I started in physics. I got shifted into the world of design and buildings by a summer program with Bucky Fuller, and I ended up sort of pursuing that. I did some consulting in the real world for a while after college, but when this opportunity opened at Berkeley Lab, this was just after the oil crisis, 1973 oil crisis, where people said, gee, we have a substantial problem here. What can we do? Or is there anything we can do about it? Is there some way that science and engineering can help us solve those problems? And I decided to sign on and see if that was the case. And the rest, as they say, is history. So one of the first things I got involved in was Windows, because windows are an obvious weak link in buildings. They were back in 76, you could argue. I mean, they're much better now, but there's still challenges today. So I've been involved in that, and I had the good fortune of being at a great institution with lots of wonderful people. I focused my technical work in Windows and glazing, but I did manage the whole building technologies department there for a long time. My sort of original focus and my love, I suppose you could say, was Windows and glazing. So that's the 90-second version.
Well, all right. So for and tell me about your family members or people around you. Hearing that you've been focusing and working on Windows for 50 years, I'm sure they'd say, well, wait a minute, Windows are pretty straightforward. So where do you think that the major disconnect is between how complicated, executing performance and longevity and durability versus people just look at it and they're like, what are you talking about? You can go to Home Depot and pick up, Marvin or Anderson window. How complicated could it be?
Yeah, I think they have that view, but they also have the view everyone sat in front of a window where it's been too cold or too hot or too glary or something like that. So the good news is that it's a part of the building that they pay attention to, as opposed to the insulation in the attic, which is largely unseen and so on. But having said that, it's complicated. And they're on board up to the point where someone says, okay, if you want to make this improvement, here's what it will cost. And then all of a sudden, oh my God, it's going to cost money, or what's the payback? And the payback issue, the payback issue is real. If you're doing building codes and standards, most of them are based on some type of economic analysis that says that there's a return on your investment. But if you're in a home, what's the payback on the granite countertop in your kitchen? What's the payback on having a third bathroom in a house? So much of the time, we don't talk about payback. We talk about function, we talk about value, we talk about things like that. And I think those issues pop up with Windows. You can attack it both ways. We can put our engineering hat on and we can talk about energy savings and all the performance attributes that are out there and that we can capture. And you can also talk about view and daylight and all of the wondrous things that make people choose Windows. If you give people a choice, there have been experiments in the past. You walk them into an office and say, do you want to work in office A, B, or C? Almost always are going to pick offices with bigger windows and better views. So I think there's some intrinsic interest in that. The challenge is, can we do that in an environmentally sustainable way? And the short answer is yes. The longer answer is, but the details of how you do that depend a lot on lots of other details: climate, orientation, building type, some aspects of your personal life, and so on. And trying to unravel all that, unravel it, but also get it to the point where it can be routinely solved, where that problem can be solved easily. If it's a really complicated problem, then people will say, the hell with it, we'll just move on to something else. Maybe we'll tune up the HVAC this year or something like that. So there's pluses and minuses to the fact that everyone knows about Windows.
Well, okay, so what you just said about people walk into an office, ABC, they'll choose the one floor to ceiling glass with the views, but how does that apply to where somebody would want to live?
Yeah, it's a little bit of a different thing, but for example, view is really important, right? And view is something that you react to immediately. There's a lot of interesting work going on these days in terms of the spectrum of daylight that comes through windows. Coatings can change that spectrum. You can cut off the UV or the IR, things like that. That's something that the spectrum of light of daylight has an impact on people, but it's not an obvious impact in the same way that a view is. If you cut off a view, it's understood instantly. But even view has a downside, right? you want privacy and security. So view doesn't mean that you want to be open all the time to the outside. It means that when you want it, you have it, but when you don't, it's cut off. And so that gets us into operable shading, smart windows. And I mean, there are solutions to all of these challenges, but I think one of the key issues is that in terms of, well, let's compare it to a wall. In most cases, with a wall, you just want a highly insulating wall. There's some other details you could talk about well, anyway, there's some other details you talk about. We need to. In the case of a window, you want it to be transparent and clear as long as there's a view and as long as there's daylight and so on. And maybe you want it to be transparent to solar energy in the winter because that sunlight warms you up. But if it's August and the sunlight is beating in and your AC is on, you don't want that sunlight coming in, or you want the view, but you don't want the sunlight, or you don't want the energy intensity of the light. So you quickly get into a lot of trade-offs and challenges that people understand conceptually. I mean, they understand the fact that you want the sun in the winter, you don't want it in the summer, but exactly what does that mean? It depends on orientation, depends on climate. It can be done by the window itself. It can be done by exterior shading, interior shading. There's a whole host of options that you can go for. Now, that's good. The fact that there are lots of options is good, but that's why we need architects and engineers and others to help us solve that. In the case of a home, it's not as complicated a problem, and there are lots of solutions out there. And maybe you can, with some help from a friendly person at Home Depot or your local window store, maybe you can solve that. In the case of a 40-story office building, it's a bit more complicated. You need to make sure that you have the best architectural and engineering advice. And that can get pretty complicated, and gets more complicated if you want to bring in issues like carbon, embodied carbon in window systems. It gets more complicated if you want to look at some of these health benefits or health effects over time. You have to worry about life safety issues, right? Breakage, earthquakes, fire. These days, living in Southern California, as I do now, a lot more sensitive to glazing and fires, or what happens to windows and glazing with fires. So there's a whole host of issues, and in the end, one needs to deal with all of them and deal with them appropriately, but then it needs to be done in a way that's, I guess, leads to action, as opposed to, oh my God, this is so complicated. You just sort of throw up your hands and move on to something else. And there's always a danger of that. Now, the other thing I would say is that the technology solutions that are available in each case, the good news is, they change over time, and they get better over time. We look at what we started with in the 1970s. We kind of struggled to go from single to double glazing and a bunch of things there. And now we have glazing that's effectively as insulating as a wall in some ways. So we've come a long way there. The challenge is, are they available? Does your local architect and engineer know about them? Does the supply chain provide them? How costly are they? What's their lifetime durability? So there's a whole host of issues. When something's new and different, you kind of worry a little bit about, is it going to last 20, 30, 40 years the way the older units did? So there's just a host of issues there that jumps in and makes things more complicated.
You look at the pie of like the best top performing, 20% best performing, top performing envelopes in the world, 20 worst performing, and then 60% is somewhere in the middle. Where, in terms of where you were trying to have the most impact and where your time was spent and what you had the most access or exposure to, what was it? The bulk of the market, or were you always focused on sort of the cutting edge, leading edge, new innovation that was coming?
Yeah, that's a great question. I mean, the simple answer would be both, in the sense that you start by focusing on the leading edge, but your goal is to make them standard, routine, and used everywhere. And if we turn the clock back to the mid 70s, the challenge there was most windows were single and double glazed, and they were a real problem in terms of energy loss. I mean, at some point, I think we calculated the energy loss from windows in the U.S. was greater than all of the energy supplied by the Alaskan oil pipeline. There are lots of ways of making comparisons like that. But I mean, so it's a big effect nationally, and that was why it was important for the Department of Energy to start to work on it. But of course, that is also important at the home level. It's important in terms of comfort. It's important in terms of your monthly energy bills. And so I think the answer is, in terms of the research we were doing at the time, we were looking for things that were breakthrough, that would really make a difference in people's lives. But we were always aware that, or always focused on those that could be scaled. If it was interesting technically, but it wasn't scalable, then frankly, it wasn't something that we were paying a lot of attention to. And that's one of the keys. And I think that's true. There's a lot of applied research that goes on today, but most of it funded by state agencies, by the federal government, others have that ultimate application in mind, which is good. And it slows, it limits your options slightly, but not in a major ways, and it adds new challenges that make the research even more interesting at times.
So where do you think the biggest opportunity is today to have the greatest impact on what's really advanced? We've talked about some of these technologies, dynamic vacuum, thin triples, quads, and so forth. Let's call that on the leading edge. The worst is, where we're putting in annealed glass, not even insulating at times, not even putting in thermally broken frames. And then standard, call it, is your minimal thermally broken systems with double glazed, one low E, 40% window to wall ratio. So where do you think we could move the needle the most?
Probably in that middle section, taking the group that's doing the code compliant solutions today, but bumping them up a step or two. That was the philosophy behind the Energy Star program on the residential side. So to start with where you are, but let's take the next step. And every 3 to 5 years, let's go back and look at what that next step should be. And they always based the new requirements on solutions that were market viable and cost effective. So it wasn't just that you could make them, but they would pay back in 5 to 10 years, something like that. And it's a chicken and egg there. Most of these things, manufacturers are interested and willing to update and upgrade what they're doing, but they want to make sure that when they're finished, that it will be sold, right? And so they don't want to make R&D investments that are just going to sit on the shelf or sit in the warehouse. So I think having programs like Energy Star that encourage, and then once you have Energy Star as a set of criteria, then you can get a utility to offer a rebate program. We get other organizations to offer rebate programs. Codes and standards can be based around that. So there's this, if you step back, it's a moderately complicated ecosystem of standards and requirements, of companies that build products, of architects and engineers who specify them, of homeowners who hopefully say, yes, let's do that and write the check for it. And that ecosystem evolves over time. In the 70s and 80s, it was, well, first it was moving from single to double. Then it was kind of, well, okay, after we go to double, what do we do next? And then in southern climates, as we built more in southern climates in the 80s and 90s, it was, oh, wait a minute, air conditioning is the issue now, right? So what do we do about solar gain? Well, you can tweak those low-E coatings, which we had developed 10 years before for insulating purposes, but you can tweak them to keep the sun out or the solar impact of the sun out, but let the light through. Spectrally selective coatings do that, right? And that became a huge issue in the commercial sector, where almost always, because of the heat balance in an office or a commercial building, you want the daylight, you want the view, but you don't want the solar heat associated with it. So there's been a series of innovations over time that have sort of moved the needle, and both move the research needle in terms of what's technically possible, but move the market needle in terms of what the standard product is. I mean, low-E, when I started, low-E didn't exist. Today, low-E is 90% of the market, and we have curves that show from the 70s to now what that penetration was. And it bumped around a little bit, but it increased all the time. And of course, as sales go up, then the manufacturers invest more in R&D. They make better products. They make cheaper products. The products that are available are more widely specified. I mean, I can't tell you how many times either I myself or have heard stories where someone says, gee, we heard you talk about these new thin triple windows. We went to our local supplier and asked about them, and they don't know anything about them. And if they don't know anything about them, well, why am I going to specify them, right? So that process takes time. I mean, it takes time, and if you think about cell phones and laptops and computers, I mean, that stuff evolves fairly quickly. Things like Windows, that market evolves much more slowly, and there's some value to that in the sense that if your cell phone isn't exactly what you want, you can replace it fairly easily without a lot of disruption. Otherwise, if the windows aren't what you want in a house, that's a big deal, and you don't want to make a mistake there. You want to do it right the first time. But that first time, I mean, so I've lived in houses around here for maybe 50 years. What I would have thought was the best solution 50 years ago is probably not exactly what I picked today. Also, it's interesting because I just moved from the Bay Area to Los Angeles, and in the Bay Area, you don't have air conditioning, and the climate is a certain way, and you think about windows a certain way in terms of orientation and view. Now in Los Angeles, all of a sudden, I'm sweating in the summer, and I got to worry about that solar heat gain. I've got an automated shade in the office I'm sitting in now. So anyway, they're climate specific. They're building type specific. And the good news is there's lots of opportunity. The bad news is there are some challenges, and it takes some time and effort to get the right solutions.
So what you just spoke about in terms of codes will be dictated, codes will be enforced, market will adopt. The market every 3 years has the energy code revision, and there's discussion, like you said, about availability of products, what's realistic, and thus far the markets have been adopting, so or adapting to the requirements. So if the products are readily available and we're seeing large commercial markets implementing these at scale, isn't the low-hanging fruit, like we said, maybe those specific jurisdictions or cities live in that 10 to 20% region of the extremity. But, at what point do we have a stretch energy code, the equivalent of an Energy Star program everywhere for the commercial market?
Well, that's an interesting challenge, and the Facade Tectonics Institute has sort of jumped into that one, and we wrote a report last year for the Department of Energy, which basically was what are the barriers to the adoption of the solutions you're talking about? And unfortunately, or fortunately, I mean, unfortunately, there's a whole long list of those barriers, right? The good news is we talked to 50 or 100 people and sort of over a couple of months worked out what they were, how were they related to each other, and what one could do to unravel them a bit. And we have a second phase now, which is to look at some type of above code program that will help us take the first steps there. I think, again, the message in all this is you want to move, but you want to move somewhat carefully. And I guess I wouldn't say you want to move slowly. You want to move cautiously, and you don't want to do something that will leave a bad taste in everyone's mouth, and they're going to say, gee, I'm never going to touch those energy efficient windows again, right? The other thing is, if you think about it, you were talking about Massachusetts and other places. The good news is in the 50 states, there are some states that have jumped ahead and are tackling these programs head on and really working great success. On average across the country, there's an awful lot of states that haven't adopted codes that are 10 or 15 years old. There's a big range across here in terms of what people or what organizations are doing. And the same is true on the utility side. There are utilities that are aggressively supporting some of these innovations. There are others that are basically, I mean, if you talk to the utilities today, the only thing they're talking about is how do we provide power to the new data centers and AI processors, right? And window buildings have kind of faded to the background a bit. That'll change eventually. But yes, so I think what's good if you've got all these different states doing different things, what's good is you can look around and find models where they're working and then replicate those models elsewhere. And it's a lot easier to say, why don't you try a model like this? Because Massachusetts has done it for the last 5 years, and you can go talk to the architects and engineers and owners in Massachusetts, and they're happy with what's going on. They've solved there have been problems, of course, with anytime you innovate, you change. There are problems, but they've identified them, they've solved them, and moved on. And the fact that they've done that now presents a model that someone else can adopt with much less risk and much less hassle. I'm actually all in favor of solutions that are tried out in different locations, and the best ones, ideally the best ones, flourish and succeed and replicate themselves. The ones that didn't work die and fade away as they should. If you try to do it nationally all at one time, you would undoubtedly create a lot more chaos and confusion. So I think there are probably some simple things you should do everywhere all at once, but in general, the things we're talking about now are more complicated. You also have to worry about the supply chain, right? If everyone decided next week to only specify triple glazing, the market probably couldn't immediately handle that. It might, it could over time. Sorry.
You don't think so? Because I hear that, but at this point, if you're doing it in Seattle, you're doing it in Massachusetts, you're talking about the extreme zones of the market, and enough fenestration suppliers that can service it. There's enough insulated glass fabricators that can service, and like you said, the others will either adapt and ramp up their equipment, or they'll fall off.
No, right. Let me be clear. I think triple glazing, as an example, is a solution that works across much of the country. There's a few, we could talk about the technical details of some hot climates where there's some challenges, but it can still work there too. The issue isn't that it couldn't or shouldn't. The issue is that you literally don't have the capacity to, if you change in a step function and went from, I think triple glazing is on the order of 5% now. If you try to go a 5% of a market to 80% of a market in any market, in anything, with supply chains the way they are, that's a step change that's actually rather complicated and difficult. I don't know enough about the details of how rapidly an individual company could adapt, but it would take a little while. But it would take, a year or two. It wouldn't take 10 or 20 years. So these are things that can and should happen much more rapidly than they have. I mean, from my point of view, 2/3 of the country should be roughly triple glazed equivalent. I mean, it could be vacuum, it could be other solutions. Because if you look at the cost benefit, you look at the energy or the heating impact of windows across 2/3 of the country would justify windows with U values or R values roughly equivalent to where triples are. And what we talk about, if you want to talk about where we should be going, we talk about a net zero window or something like that, which is a window that on an annual basis consumes net zero energy, which means it probably saves a little bit of energy in the winter. It could actually have an energy surplus in winter because more energy comes through from sunlight than is lost through these low conductivity glazings. And then it manages the solar gain in the summer, so the cooling impact is small. So if you do that, we've done studies for 25 years that show that, and that depends on orientation. A south window is easier than a north window, right? Because there's more solar gain in winter through a south window. We've done studies for 20 years that show that's technically possible. Whether you can get people to do it is another challenge or not. And that's where this sort of time comes in. You want to have solutions out there that work. People can see that they work, and then ideally they say, "Gee, I want that solution also." You can force people to do it with codes, but if you can get them to do it because it's something desirable in the marketplace, that's a better approach, I think, than having codes is critical because you don't want people to do stupid things because, frankly, they're too lazy or not, or they don't care. People have lots of concerns in life, and the U factor of a window is usually not one of them, right? So you want to make it easy. The other thing we were talking about, the adoption of low E when that started, you have a product that's invisible, right? If you go from single double glazing, you can see what's going on. If you go from a double glazed window with no coating to a double glazed window with low E, you really can't see it. I mean, there's tricks of how you can show it, but you can't see it. So you're selling the emperor's clothes. You tell someone window A is 30% better than window B because it has low E, and they look at it and say, well, how do I know it has low E? So one of the things that happened back starting around the, I guess, 1980s was we had to develop ratings, labels and ratings for windows. So basically the industry, with some help from DOE and Lawrence Berkeley Lab, created the National Fenestration Rating Council. So you could just have a little sticker on the window, and that window assured you that the properties of the window were what the sticker said. You didn't have to worry about the salesman coming in your door and making claims that weren't supported, right? So that infrastructure took time to build, and it's still being built. The NFRC is working on a new and improved set of ratings for commercial windows now, and it's 30 years after they started or 40 years after they started. So some parts of this move slowly, some parts of it move quickly.
And what are some of do you think, what's the major hindrance or blockade of NFRC adoption in the commercial market? Is it just because of the complexity of how custom oriented every project is, or how, in that sense, it's not as itemized or productized as the residential market?
I think that's a big part of it. Yeah. I mean, I don't know what the market fractions are, but I mean, there are a lot of standard products in the commercial market, but they're used in non-standard ways. So yeah, I think that's part of it. And I think historically they just weren't used to having those kinds of requirements. They also spend a lot of time or more time worried about structural issues, right? And things like that in the residential market. You've got a sort of a single product, and that product gets mounted in the wall. In the case of the commercial side, you're really designing a facade. Well, in some cases, you're designing a facade, and so there's a lot more going on there, of which energy is part, but it's not the only thing. And then the appearance issue is a big deal. I mean, the window to wall ratio and glazing percentage and all that has been argued about forever, and pluses and minuses, but the window that works really well if it's small may not be the right window you want if it's much larger, right? If you've got a small window to wall ratio, then maybe a more conventional double to triple works. If you've got 100%, if you want 100% glass and you want it to be comfortable and all that, then you have to go several steps further in terms of thermal properties and solar gain. The other issue is much of what NFRC rates at the moment are the static properties of the window, the USHGC TVs, those things. If you look at energy performance and comfort and related issues like that, that gets into day and night cycles, winter and summer cycles, dynamic. And the good news is we can calculate all that. It just adds a degree of complexity to what the design team has to do, to what the owner has to think about. Those are challenges. They're challenges that can be readily met if you've got the right team, but on average, it's still a challenge. And some of them are it's just physically impossible to have a 100% glazed wall, which some people would like to see, and have no challenges with glare and solar gain. There you get into dynamic operation. You either need an electrochromic type coating, you need an automated shader blind, you start talking about exterior shading systems. All of these are available, they're feasible, they work if you choose the right one, but they're more complicated. And then you get into the interesting question of how these perform over time. So in the case of a U value, it's there forever. Well, maybe that means 30, 40 years, as long as the IGU stays in one piece, right? If you're talking about solar gain, if you're talking about managing direct sun in summer versus letting the sun in winter, now you're talking about something that needs to change over time. Is it motorized? Is it automated? Do people control it? Do sensors and motors control it? Again, they all work, or they all can work, but making sure that they work in your building and they work all the time is a real challenge.
Would you assume that the U value is going to change over time, though, as you're losing some of that, you get some argon seepage?
Yeah, it probably, yeah, it would change a small amount, but the amount would be relatively small. I mean, assuming it's not a catastrophic failure.
Right.
Yeah, it could degrade over time, and it could degrade by a relatively small amount.
So if we assume we've really moved the needle with center glass U value from double, like you said, to triple can become normal, or we could look at a quad, or we could look at vacuum.
Right.
There's a path to get to the extreme, call it, but that's not applicable, as you know, to everywhere in the country. And everybody likes to say it should be triple everywhere, but it really isn't applicable when you get to where you live and when you get to Florida and certain climate zones. What is the current limitation in terms of coatings when it comes to mitigating solar heat gain? Have we really moved the needle or hit that threshold?
There's two different ways of looking at that. I think one is static solutions, and the other is dynamic solutions. On the static side, the beauty of low E, I mean, when low E started, it was all about managing the long wave IR and changing the U value of the window, and the optical properties stayed about the same. But rather quickly, industry discovered that you could tweak the layers, the number of layers, the types of materials, so on and so forth, thicknesses, and you could tune the spectrum coming through, and you could let through all of the sunlight, high SHGC. You could let through only the visible part and keep out the near IR. And so you're actually able to cut out, since that's about half of the energy, you could cut the solar gain in half without changing the daylight. And then if you want to drop some of the daylight, which you can do if you've got lots of glass, you can bring numbers down to daylight levels of maybe 0.3, 30%, and solar heat gain down below 0.2. So those are almost ideal. I mean, if you've got floor-to-ceiling glass, it's still not low enough, maybe, because you want to go even lower. But in most cases, it's really good. So basically, the evolution of low E provided a whole series of very powerful, useful, and very cost-effective solutions to control solar gain. That would let you get up to windows in the order of maybe 50% window to wall ratio, which is, remember, you have to be careful if you're talking about 50% window to wall ratio, that's almost floor to ceiling. Well, it's maybe sill to ceiling, right? Because you've got a plenum space between floors that is part of the WWR, but it's not actual viewable glazing in most cases. So you can get essentially a highly glazed wall sill to ceiling with 0.2-ish SHGC, plenty of daylight. And so now you've also got a second issue, which is glare. And even if you've managed the solar gain part, you may have a glare issue. So I think you end up with a situation where if you've got relatively large windows, you have to actively manage solar gain and or glare, certainly glare, possibly solar gain, or glare all the time, because people get blinded any day of the year. Solar gain maybe in summer, not in winter. whatever. So I think one has to be a little bit careful. And then, of course, if you're in an office environment versus a retail environment versus a hospital, the severity and importance of managing solar gain and glare is going to vary. If you're sitting in a place where if the sun's too warm, like in your home, you can get up and sit in a chair 10 feet away out of the direct sunlight, that's fine. If you're in an office environment, you're probably in trouble there. Or if if it's a hallway in a building, then it doesn't matter. If it's your office environment, it does. So I mean, that's pretty much simple kinds of decision making. But in the end, when you look at a whole building and you look at how to decide the facade of a whole building on all orientations, it starts to get a bit complicated. The good news, as I said before, is we do have solutions that work in most cases. They may go beyond what is typical practice or standard practice in some cases, especially if you start to get into the automated controls to control these things. Back on the insulating value, as you said, we've got triples and even quads and VIG that will get you down to the R10 range plus or minus, which is about as far as you need to go. That's one other interesting point too. For a while there, as we were in single glazing and double, we were always looking at how much further do we have to go. If you think about the world of chips, every 5 years, Moore's law in the world of electronic chips says you have to double the power, the density of chips every cycle, every few years. In the case of Windows, you don't have to keep doubling. Once you've got to about R6, 8, 10 in that range, the window is effectively a net zero window, as I talked about before. So at that point, you could add more R value. You could go to R15 or R20 or R25. Technically, we know how to do that, but there's no point in doing it. So the good news is we've actually got to the point where with these quads or VIGs, triples, quads, and VIGs, we are at the point where the window is a net energy supplier. But now we have to worry about solar gain and glare and management of those properties. So the game has shifted a bit, although the standard market, the mainstream market, is not yet at that R6, 8, or 10 level.
Well, what you talked about in terms of making that step change and how that might shock the market, and after a year or two, everybody might adapt to it. I believe just because I've been on the contracting side and manufacturing side, I know what's readily available and I know the price point, and I know there's not that much of a disparity between what's being bought out already. Frankly, it's just what's required by code. And if there's somebody enforcing it, and the very, very small percentage of projects that are going to want to exceed code or go above and beyond, the baseline in this country has been building what's legally required. It's funny, I had Tali and Irene on recently, and they said, the threshold is, what do we need to build to stay out of prison?
But yeah, I mean, if you build right, I've been in places where people said, "Oh, we have an energy efficient solution because we've met the code," and I said, "Well, all that means is you've built the worst building you're legally allowed to build and still put it up, right? If it was worse than that or a little less than code, you wouldn't be legally allowed to do it. So meeting code is not a mark of excellence, generally speaking, right?"
Well, and that's what I wanted to ask next in terms of like people think they're achieving code, so this must be a high performing envelope. And you have this, it's important to really think about and carry forward what you said about getting this net zero window or a window to the point of going above that is probably diminishing returns. It's really all we need, and that's rather readily available in the market. Where do you think the big disconnect is right now? And was there a disconnect in the 2010s in terms of what people were trying to achieve, maybe going after certain lead requirements or certain things that we were at one point pursuing, where we said, you know what, this is not getting us very far. We need to pivot and go in a different direction. And do you think when we look back in 2036, at that point, we're going to feel a little bit better about ourselves in terms of, what changes we were making to get us where we need to go?
That's a tough one. And I think also in the end, the market is fragmented, and there'll be parts of the market that will do what you're talking about, and there'll be other parts of the market that will be kicking and screaming forever to, why the hell do I have to do anything more than a double glazed window? I think if you look at mainstream, if you look at the mainstream markets, I see continued progress, not as rapidly as we would like or we would hope. I think the current situation in the U.S. where you've got some national requirements and standards and codes, but you've got a lot of state activity. As I said before, I think it's good that a variety of different states are trying things out or being a lot more aggressive. And if they work well, then I would expect and hope that other states will pick up on them. The other way to look at it too is on the market demand side. You see projects going up from owners and architects and engineers who are at the cutting edge, who are breaking new ground and learning new things. And I think in some cases it's owners that have pushed the boundaries a bit. In other cases, it's the A&E teams that have pushed the boundaries. In some cases, probably the manufacturers, the ones that have come up with the innovative products, the thin triples and quads and the VIG. So there's a lot of push-pull going on here, and the ideal is when I think you get an owner that wants to do something innovative. They've hired the right A&E team, so they're comfortable and on board and raring to go, and they find the vendors out there who have the products they've been on the shelf for a while or just offered to the market. And all of that converges, and you get some really spectacular buildings. And we've been involved in a few with the work at Berkeley Lab where we go in after they're built and measure them, or help them build mock-ups, a part of them, measure them, tweak the design, build the building, and then go in after it's occupied. This is like the New York Times building 20 years ago. Built a 5,000 square foot mock-up, brought in the technology, automated shading, dimmable lighting, external shading, all these things. And then after the building was occupied, did an occupant study for a year, measured the energy performance, measured the occupant satisfaction. And the good news was it all worked. The bad news was, and then we figured, great, everyone will do this now. But it didn't quite happen that way. So, but you got to keep trying that, and other groups have done similar things. So I think there's an innovation cycle there between all the different players in the industry. The challenge I see is, how do we accelerate that? How do we make it go faster? How do we iterate more rapidly? And then, the problem in the building sector in terms of electronics, getting back to the cell phone, you can iterate here in 6 months or whatever. If not the life cycle, just the design build cycle of a large building is 5 to 10 years, something like that. It can be. That means if you learn something in that 5 to 10 year cycle and want to apply it to the next one, you're moving relatively slowly, right? So somehow we have to overcome some of that. I mean, I think the opportunity is basically identifying best practice across the full spectrum we've been talking about, and highlight that, and then try to replicate that as many places as possible, and encourage it by building codes and standards, encourage it with utility incentives and rebates. We're going to try to put some of this package together with the Facade Tectonics Institute that I mentioned before, the program this was the follow-on to the Department of Energy work that was done a year or two ago. So we're trying to put together a package that will say, what is it you need to do, and how would you do it, and how can you deploy it, and who are the partners, and what can we build on? Not inventing things from scratch, but rather trying to put all the pieces together in a package that will make sense.
Incentives, educating, and informing. I think it's a good note. So to wrap things up, I think I think the next time we'll be getting on, we're going to join with calling him out now, Mick Patterson, who's been screaming at the hillside, telling me what Facade Tectonics is up to. So I think next time we should check in, the three of us, and share that progress.
That sounds good.
All right, Steve, thanks for coming on. I really enjoyed the conversation.
Great. I did too. Thank you. Bye-bye.
Talk soon.